Start the recording. So from the statistics module, it was the last session. Okay. So we can go ahead, try to be understanding the ANOVA test. ANOVA is a very, very important. Okay. So no. Okay. Stratology. Different kind of ANOVA tests are there. One-way ANOVA, two-way ANOVA. We don't need all things, but at least one-way and two-way ANOVA is fair enough. So this, it could be analysis of variance. ANOVA means analysis of variance. Okay. So to compare the means of three or more independent groups, you might be thinking, right? Like previously we have only one group, okay, or one, or two groups only, right? But this time you just need to go with, so you can compare the one or more independent groups, whether they determine if there any statistical significance difference between the corresponding population mean. Okay, so you have a population mean. So is there any okay, so those particular group of things, is it an effect or significance is there with your population or not, that we can do with help of the ANOVA. Okay, the motivation of ANOVA and assumptions, and how we can performing the ANOVA, and with some example we can see in this particular session. See, the motivation is here. Suppose we want to know whether or three different okay exam preparation programs that lead a different mean score on college entrance exam. Okay, so you have a preparation exam. Okay, three different preparation exams. So from these three, which exam is most affected for your final score? So I want to find that kind of significance. So such things we can do with help of the ANOVA. Since there are millions of high school students around the country, it would be too time consuming cost, and around each and every student, let them use one of exam preparation. Okay, instead of, we might selected three random samples out of the 100 students. Okay, random sample of 100 students from the population. So here 100 is your sample, okay, size. So from the population, and allow each sample to use one three test preparation program to prepare that particular exam. Okay, then we would record the score on each student once they take an exam actually. Okay, this is one sample, this is sample 2, this is sample 3. Okay, so here, however, it virtually guarantee that the mean exam score between the three samples would be at least a little different. This question is whether or not difference in a significant, statistically significant. Okay, so here what we can do here, we need to go ahead with some kind of assumptions. What are the assumptions we have? It normality. Normality in the sense, when we draw that distribution, it could be normally distributed, and the variance of that all samples, it could be a same. The variance of the populations, that the samples come from the equal, so that if you want to check whether it is the equal or not, okay, we can have the bar bartlett bartlett test to verify that particular assumption. So I just want to check with whether the equal variance or not, then we can go ahead with this particular test, but let test. Okay, so independence in the sense, one group, it could be independent with another one, so both groups are not same, both are different groups. The observations in each groups are independent of each other, and observations within the group were obtained by random sample only. Okay, so the process is, first we need to defining the null hypothesis, and second one is the alternate hypothesis. So what I said, all population means are equal, so that is my null hypothesis. Okay, alternate hypothesis is at least one population mean is different from the other one or rest of the things. So we would like to go for using the either or SQL or statistics or stata or SPSS as this kind of tools we might be used to do this kind of operations, or else Python also it could be the better option for us to performing the ANOVA. Okay. See, by hand also we can do it. So when we see that ANOVA table, this is the ANOVA table. This is very, very important actually. Okay. This is your source, treatment and error. And this is the total. Okay. So the second column is sum square. This is sum square treatment or residual. This is sum square error. This is sum square total actually. Sum square total in the sense SSR plus SSE. This is degree of freedom. Degree of freedom in the sense when you're taking the treatment, you might have some kind of number of records, right? So that number of records minus one, that is the degree of freedom. So how many number of errors we have it, that is the degree of freedom. That number minus one. Okay. So when you do sum of this all things, that is your DFT. Okay. So mean square in the sense this SSR by the DFR, it could be mean square error. Okay. Mean square R and the mean square error. So mean square error in the sense SSE by DFE. This is the value we will be getting the MSE. Okay. How we can able to get the F? So F could be getting based on this mean square R by mean square E. MSR by MSE. So that's we are calling that's a way we can able to calculating the F value. So once if we have a F value and based on the degree of freedom with error, we can based on F value and degree of freedom, we can calculating the F value actually. So this is the ANOVA table. Clear? You can go ahead with any way, anything. One-way ANOVA could be looks something like this only. So SSR means regression sum square, SSE means error sum square, SST means total sum square, DF regression degree of freedom, error degree of freedom, total degree of freedom, K in the sense total number of groups, N in the sense total observations. And so this is F value, and if we know the F value and if we know the degree of freedom with error, then you can easily calculate the P value by hand. Okay, so if p value is more than significance level or less than significance level, based on that one we can reject or we can accept. Okay, so here we have some kind of note. Let's read this one. If rejecting the null hypothesis, this evidence that at least one of the population mean is differ from the other actually, but ANOVA table does not specify which population are different. Okay, see, you just saying that populations of mean populations are different only, but which population is different, if you want to determine, then we have post HOC test. This is the test will help you which group mean is differ with your population mean. Okay, so this is also known as the multiple comparison test. So when you're doing ANOVA, just you're concluding that all population means are not same, but which group population is differ, if you want to know it, then we can use the post hoc test or else multiple comparison test. Clear or not? So when you're doing that ANOVA, we are getting the two tests actually. One is what? Bartlett test. It will help you to verify that assumption equal variance or not. And second one is if you want to go ahead some more intuition, which group mean population is differ with your population, then we can go ahead with the multiple comparisons or post hoc test. Let's have some example. Suppose we want to know whether three different exam preparation program lead to different mean score on certain exam. To test this, we recruit the 30 students to participate in this particular study and split them into three groups. And the student in each group are randomly assigned to us one of the three exam preparations for the next 3 weeks to prepare for one particular exam. At the end of 3 weeks, all the students take the same exam, and what could be the which group is, or else all group people are performing the same, or all group people are performing not same, that I want to be test actually. Okay, So here, so ANOVA calculator, here we have, this is the sample 1, okay, this is your sample 2 data, this is your sample 3 data. So when we do this thing, then we would like to get this kind of table, f value and p value. If the p value is the more than 0.05, then we say that 3 group people are performing the same thing. Okay, the same thing we want to do with help of the Python programming language. See, here we have the group 1, group 2, group 3. Okay, there is a 3 groups people are there. I want to do that one-way ANOVA test. For that one, f underscore one-way function is there. So this function which is available in SciPy library to performing the one-way ANOVA. Simple, right? So we have to import the SciPy and stats model, stats library, and we need to import this particular function f underscore one-way, and we're just providing the group 1, group 2, group 3 data, which is returning the p value as well as f value. Okay, so based upon these values, we simply saying that all group of people are performing the same. So not less than 0 point. So we fail to reject the null hypothesis. So simply we can say that the mean, we don't have any sufficient evidence to say that there is a difference in exam score among the 3 studying techniques. The 3 techniques are giving the same results. So this is our final conclusion. Clear? So this is the way FA ANOVA we can use it. And here we have a two-way ANOVA. Two-way ANOVA in the sense we have a 2 groups. So two-way ANOVA to determine the whether or not statistically significant difference between the means of 3 or more independent groups as split on the 2 variables, sometimes called as the factors. So factors in the sense, previous thing is that we have a number in the groups, we have a numbers, right? See, factor in the sense, maybe the dependent variable, it might have some kind of categorical data. Okay, so when we have a categorical data, that we are calling it's a factors. Actually, when we have a factors in your dependent variable, then I want to go ahead with the two-way ANOVA test. Okay, sometimes it was included the interaction means, so combination of those two groups also. We should use the two-way ANOVA. We would like to know that the two-factor effect is a response variable in the sense dependent variable, two-factor effects in response variable, and whether or not there is any interaction effect between the two factors and the response variable. Everything we can do it with help of the Python, or same question, same thing, you just have that, slightly different, no, low, medium, high, right? And a daily and weekly. Okay, this is one group, and weekly one group, this is also days only, right? Okay, so what returning frequency and sunlight exposure, low, medium, and high. So here we have a categorical variables. Okay, so when we have a factor something like this, I would like to go ahead with the two-way ANOVA. So how we can do with help of the Python? Simply we can this is the data. Okay, so water, sun, and the height. So this is my data set, I have it. So water and sun and height. Okay, so like this we have some kind of records, we have it. Out of that one, sun could be the low and medium, we have it, and water, it could be the daily or weekly, we have it. So we just showing only few data elements. So repeat daily and weekly 15 things. Okay, NP, NumPy is the one library. So inside of the NP, we have a function is that repeat is there. So we are repeating the daily and weekly 15 things. Okay, and so title is okay, tile. So NP dot tile, and we are repeating that low, medium, high, and 5 okay, with this 2. So here height, we have total 15 records. Okay, this 1 5 5 10, right? So 10 10 and 10, how much? 30 records. So height could be the 30 records, and we are repeating the 3 things, right? And so 2, this 3 is repeated 5 times. So 3 into 5 15. So this 15 again it can be repeated two times. Okay, so 15 into 2 30. So your son having the 30 records. So here we have the two records, right? So daily and weekly. So we are repeating, each one is a 15, so 30 total. This data frame having the 30 samples. Okay, so water and sun and height, each one having the 30. So here we have the categorical variables, so sun and water having the categorical things. Okay, so what I should do, that here we have to import the statsmodel.apa and statsmodel.formula.apa. We have the wireless method is there. This wireless method, you just, it is your response variable, and which is depending on the water and sun, right? And this is the interaction formula. This is the interaction formula. Okay, so water and colon and sun, this is the interaction formula. So when we are importing this library, and we're importing this library as well, statsmodel.api and sm, and with this one we are importing the stats and ANOVA and ANOVA underscore LM. So when we, after you creating the model with help of the wireless, with help of the wireless, we are creating the model. And after you creating the model, then what we should do, actually we are going through giving ANOVA underscore LM function, which is giving the water sum square, degree of freedom. And so water we have only daily and weekly, right? 2 minus 1, it's a degree of freedom is 1 only. And sun we have the 3, right? 3 groups, right? So 3 minus 1, it's a 2 only. So water interaction, water and these things, right? So 1 into 2, it could be the 2 only, right? Okay, so residual, this is the residual. So water, sun, and interaction with water and sun, and this is your residual error. So f value of water, or this is the f value, and f value water, and f value for sun, and f value of interaction. And you're not calculated the residual, because of this f value can be calculated, this, no, this MSC by df only, right? Okay, okay, this is mean square error. After you calculating the mean square error, we can calculate the f value. F value can be calculated by the mean square water by the mean square residual, and mean square sun by the mean square residual. Okay, so that's the way you can do it. So automatically these things you will be getting an output. So here the p value is less than the 0.05, right? This is also less than the 0.05, but water interaction, it could be the more than 0.05. These two are the significance. Water and sun are the significance, and interaction is not significant. So here, since the p-value of water and sun both less than the 0.05, this means that both factors are statistically significant. So if the p-value is the less than the 0.05, which means that statistically significant. If the p-value is the more than the 0.05, statistically it is not significant. Since the p-value of interaction is effect is not less than the 0.05, this tells that no significant interaction effect of your sunlight and exposure. Okay, and I want to go ahead with the post HOC test to determine the which group mean is differ. Okay, although ANOVA result is a watering frequency and slightly exposure, we have statistically significant on plant height, and we would need to performing the post HOC test to determine the exactly how differ levels of water sunlight effect on the plant of height actually. Okay, so for this one we just post HOC test to help you. Okay, so this is the way we can groups different groups, and the comparison of this means, and if this is the p values. Okay, and which p values you are uh, mm, greater than 0. Less than the 0.05, then which are the statistically significant, and rest of the things are not statistically significant. So your head you're creating the data frame and convert the long data set in for ANOVA, and then after Tokyo test also will do the same thing. So we would like to apply the ANOVA, and we are seeing that, okay, this is our language, this is the code which related that R. that we can do with help of the Python also. We can do the same thing as Python also. Okay. So guys, so ANOVA and two-way ANOVA and one-way ANOVA could be almost similar, but no, one-way ANOVA it could be no numerical things, but two-way ANOVA it should have some kind of factors. Okay, so if you want to more intuition of that things, we can go ahead with the post HOC test. Like this is never-ending process statistics. We have to spend a lot of time and keep on get a lot of articles. Okay, so when you want to become like a data analyst or data scientist, statistics is pretty much important actually. So don't stop learning of this all things, and when we have a time and spend more time on this particular website and tutorial, and definitely you will be getting a lot of information. Okay. Yep. So that's for today's session guys, and hopefully we were done the statistical information. And so Arvindo, we have a sessions from Monday onwards in a different times which are machine learning. I will message you separately. Okay, even Jagdish and Ramalakshmi and Kunal as well. Bye, take care.
Bye, sir. Happy Pongal, sir.
Yep, you too. Thank you. Bye.